Hello everyone and welcome to the channel Binpipe Schools, and I am Bijayalakshmi with you. I am there to discuss about motion. In the first video, I told you about the definition of motion. Then I even told you about the frame of reference. We learned about state of motion and state of rest. Now today I am going to discuss about two physical quantities, that is distance and displacement. Now, henceforth, we will be learning more about physical quantities, which is useful in study of one-dimensional motion. So, without wasting time, let's begin with distance and displacement. I'm going to share PPT so that you can understand more better. And even at the end of the lesson, I will be telling you about, we will be discussing about question answers. So let's begin. Now in our portion, which is to be studied, we will have distance, displacement. Then after this, we will have a comparative study between distance and displacement. Then I will be telling you about some real life situations like problem solving, which will be helpful for you for doing your class assignments. And then at the end, we will reprise on the lesson on whatever we have learned. So let's begin with distance. Now, distance, as it is said, is the total path that a body takes to cover, or you can say the total path traveled by the body. Total length of the path that a body takes to cover is called as distance traveled by that particular body. So, if you take an example, Mr. X. Now, Mr. X wanted to visit this ice cream parlor. Now, how will he come? He will have to cover the whole length of the path to reach to his destination, isn't it? So, this is what he covers the distance. So, distance moved in the path is distance moved is nothing but the path covered along point A to B. Now, distance is always considered as a scalar quantity. There is a video on scalar and vector where you can understand why some quantities are called as scalar and why some quantities are called as vector quantities. Distance is considered as scalar because it has only magnitude but no direction. Now, then the distance is generally represented as letter S. What is the unit of representing this physical quantity? We have the SI unit of distance as meter and CGS unit as centimeter. Sometimes kilometer is also used, so there is nothing to worry. If all the units in the question is given in kilometers, you answer in kilometers. But it is generally preferred to convert all the units in SI system. But if some of the units given here in the question paper is in SI system and some of them are in higher or lower units, it is always advisable to convert it into SI unit and solve your sums, right? So at this end of the slide, we have concluded that distance is nothing but the path, total measure of the total path covered. Okay. Now, another point that is to be discussed is distance is always positive. Now, what does it mean? Whatever length you cover, it will be always positive. That means distance is nothing but the absolute value of a given point, of two given points rather. So here, for example, I have taken a x-axis, and along the x-axis there are certain points mentioned. You can say right from the center 0 to right hand side we have 1, 2, 3, 4, 5, 6 mark, and on the left side we have -1, -2, -3, and so on. Now suppose we consider 2 points, point A and B. Point A is in -5 distance and point B is at -1 distance. Now if you are asked to find out the distance between A and B, you have to write -5 minus of -1, because it is asking you to find out the distance between two given points. So we have to subtract from initial to final or final to initial. So we write as -5 plus 1, that is -4. Now since it's just a difference, or you can say distance is just an absolute value, that's why -4, absolute value of -4 will always be 4. Even manually, if you count, the number of units between the two given points is same, isn't it? It's just covering 4 units. So here the distance is 4. Similarly, if you are asked to find the distance between CA, so what are you going to write? You have to write 5 minus of -5, the end position. So it will be 5 plus 5, that is 10. Absolute value of 10 is 10. So this is how it is concluded that whatever be the distance, whatever be the starting point or the ending point, the distance is always be considered as positive. And this is the reason behind that why it is always positive. Now let us next talk about displacement. Displacement is the shortest distance between initial and final position of the body along a particular direction. Now remember the 2 points given in this definition. One is the shortest distance between 2 points. Another point is in particular direction. So these 2 things define displacement. What is that? Now Mr. X, again we are taking Mr. X. Mr. X this time wants to visit the ice cream parlor, but he is clever now. He won't walk all the way through the curved path. He has found out the shortest route for the destination. So what he has chosen? He has found out a straight line's shortest route. So the thing that he has discovered is nothing but he has calculated the displacement of that particular displacement between his position and the shop. Okay, so the magnitude of the shortest distance moved from initial to final position is displacement. And remember, displacement is always along a particular direction. So here the displacement will be towards this shop. So you have to not only have to write or mention the magnitude, we always have to mention about the direction. It will be a vector quantity because it has magnitude as well as direction. If a quantity has magnitude as well as direction, it is always taken as vector. The displacement is represented as letter S with an arrow sign at the top. That is an indication of vector. So this indicates that displacement is a vector quantity. Next, the unit. If we talk about unit, it is same as distance. Okay, so it will be sharing the same SI unit. It will be meter and CGS unit as centimeter. Now let's compare between distance and displacement. What does it say? Or we can conclude here that distance is the total length traveled by the body at certain time, whereas displacement is the shortest distance covered by the body at given time. So here one is total length, another one is shortest distance. Distance has only magnitude, so it's a scalar quantity, whereas displacement has direction and magnitude. Hence, it is a vector quantity. There is a sharp contrast between these two quantities. Distance is completely depends upon the path of the object, or you can say path covered by the object, whereas displacement depends on the path covered by the, it does not depend upon the path covered by the body. Displacement does not depend upon the path, whereas distance completely depends upon the path traversed or covered. Now, distance can be more or equal to the magnitude of displacement. This is a vital point to remember. Distance can be either equal to displacement or it will be more than displacement, but it can never be less. Now, displacement can never be greater than distance. How? You will understand in the next slide. Magnitude can never be greater than the distance. Remember, in displacement, its magnitude can never be greater than distance. Now, distance can be 0, or even if the displacement is 0, distance cannot be, it can never be in fact 0. Because when you are asked to find out the distance between two given points, there might be some distance between it. Okay, otherwise we can never say it's a null distance. Whereas in case of displacement, we can have 0 displacement. How and when, I will be discussing later. Displacement can be 0. Okay, now let's follow the slides so that your understanding will be more clear. Now consider this 3 cases. Like the magnitude of displacement is either equal or less than distance. As I said, displacement can never be more than the distance. How is it? It's happening. Let's see here. Now suppose a body moves from point B to point A. It's covering a straight line path. So the distance is given as 5 kilometers. What does it mean then? It's covering 5 kilometer distance, straight distance. Now, if you are asked to find out the displacement, the shortest distance covered, that means here we don't find a shortest distance. Just shortest distance is just same as the distance covered, isn't it? Because it's covering a straight line path. Now, if a body covers a zigzag path or a curved path, then we get a shortest distance. There, the displacement becomes automatically lesser than the distance. Right? Like in case 2 and 3. If it is a curved path, see here, if it is curved path, approximately, it's given here 500 meters. Now let's assume as 500 meters. Now the distance is 500 meters. But is the displacement 500 meters? Do you think this distance will be 500 meters? No, it is rather less than 500 meters. Similarly, if the path is zigzag, like from X to Y, it's written here the zigzag path equals 8 meters. But do you think the displacement will be 8 meters? It can never be. It will be less than 8 meters, right? So these are the cases. So here I think your concept is clear that how the distance is always more than displacement. It can be equal, but it can never be less than displacement. Now let us consider another example here. Now how to calculate displacement. Shortest distance, if the displacement, you can say, or I can tell you the story of Mr. X again. Now let's say Mr. X is traveling 6 kilometers towards east. And then he turned and traveled 8 kilometers towards north. Now here you can see he has made a a right angle path. Now, since he has made a right angle path, so from here, point P to R, we can consider as the shortest distance. Now, PR becomes the hypotenuse of this right angle PQR. Now, when it is asked to calculate the distance, we simply add 6 and 8 because this is the path he covered. He walked P to Q, walked or cycled, whatever. P to Q, he covered 6 kilometers. Then Q to R, he covered 8 kilometers. So total distance covered is 14 kilometers. But when we talk about displacement, when the question comes, what is his displacement? How are we going to calculate? We have to use Pythagoras theorem. Now here, according to the theorem, we know it's just square root of the squares of perpendicular and the squares of base. Perpendicular is 8 square, that is 64, plus 36, that is 100. Root over of 100 is 10 kilometers. Next, the distance is always positive, whereas displacement can be positive or negative depending upon the direction. Like the distance is always considered as positive. I have already discussed in a few previous slides that distance is always considered as positive because it's an absolute value. Whereas displacement can be positive if it is considered to be in forward or backward direction or some. So they, in that case, we can take a positive displacement or it can take a negative displacement. Now, the next point to discuss is the displacement can be 0, but distance can never be 0. The best example that we can take is the path covered in a circular or distance, or you can say a circular path. Now, if a path is circular, so where will be the displacement? Displacement will be 0 because the person, if he starts walking along a circular path and he will reach the same path again after some time. Now, since the journey began from one direction and reached the same point, so that's why it is taken as 0 displacement. But if you consider the distance covered by this path, or distance covered on this path is nothing but the circumference of the circle, that is 2 into pi into the radius. So here is the difference. The distance can never be 0, whereas displacement can be 0. Now, if the body comes back to the same position after traveling, the displacement will be 0. Similarly, if you take a curved path like this, now follow the curved line. From A, it reached B, again it turned around and again came back to A. That means it is starting from the, returning back to the same point where it has started. That's why the net displacement will be considered as 0. Now let's move on to some of the practical sums which you are going to face. Now let us consider the first question here. Sam starts from home and travels 12 kilometers due east and 5 kilometers due south. Calculate his distance and displacement. Now, in order to solve this, I will be showing you or sharing my screen with the camera. So that will be clear. You can see how we can solve it. And let me know if you are facing any problem in this way so that I can devise some other method to show you and make your understanding much more better. Now, in the first question, what has been given? The first question, and we all know that there are 4 cardinal points, that is north, south, east, and west. Now, what is written in the question, that Sam traveled 12 kilometers towards east. And then he turned and went 5 kilometers towards south. Now we are asked to find out the distance and the displacement. So first we will write distance traveled is equal to 12 plus 5, that is 17 kilometers. Okay. But when you are asked to find out the displacement, so displacement will be the difference between the starting point and the final point. So for this, what we have to do? We have to find the shortest distance. Now, shortest distance will be nothing but the hypotenuse of this right angle triangle. So for that, we have to use Pythagoras theorem that I explained before. So you will write displacement, or you can write Sam's displacement is equal to square root of 12 square plus 5 square. That is 144 plus 25, or square root of 169, that is 13 kilometers. So this gives us the answer. Displacement is 13 and distance is 17 kilometers. So this is how you are going to solve in case you have been given with asked to find out the distance and displacement. Now let us move on to the next question, that is question number 2. Now question number 2 is asking that a girl travels 4 meters towards north, 3 meters towards east, and then 6 meters towards south. Understand this one. This is a bit zigzag. Like a girl travels 4 meters towards north. Again, it is traveling. She is moving on 3 meters towards east. North going up towards east, 3 meters. Then again coming down 6 meters. So let's find out. So again, we have to keep this in mind, that whenever you are solving these type of sums, you have to draw the diagram. Diagram comes useful. Okay, without diagram you cannot picturize or think how it is going to be solved. So the girl moves from, suppose we have the girl here. She is moving from point A towards north, 4 meters, then turned around towards east, 3 meters, and then came down 6 meters. Okay. Now when you write here like this, 6 meters, let's name it A, point B, point C, and point D. This is the final point where she reached. Now, when you are asked to find out distance, this is easy. This is quite simple. The distance traveled is equal to 4 meters plus 3 meters plus 6 meters. That is 13 meters. Simple. The displacement of the girl. Displacement. Finding out displacement, we have to use a simple geometry here. Like displacement is nothing but the shortest distance. Now for shortest distance, what you are going to do? You have to join this two sides. Now to join this side, we cannot find out in mathematically like this. What we have to do, we have to take the help of our geometry. Like this was 3 meter, this side will also be automatically 3 meter because it's a part of a rectangle here. And if it is 4 meter here, we get 4 meter this side. The opposite sides will be 4 meter. And what is the remaining length is 2 meter because the total length is given to be 6 meter. So we got the base, we got the perpendicular. Can't we find out the hypotenuse? Yes, simple. The same method, like square root of 3 square plus 2 square, that will be square root of 9 plus 4, that is 13. Now square root of 13 is 3.61 approximately. Okay, this is the value it's going to come, 3.6 meter. Now here a bit of mental calculation is required, but it's very, very important to show your diagram. Otherwise, you cannot solve your sum correctly. Clear? Now let's move on to our next question. That is question number 3. Now let's see what it says. Sorry. We had covered this, yes. This is what we are going to see. A car is moving along a circular path of radius r. What will be its distance and displacement when it completes half revolution? Now here is the twist in the question. That like I had discussed about the total revolution, but here it's given when it is half of the revolution. So it's simple. What we have to do, we have to find the half of the perimeter to calculate the distance, or half of the circumference. And similarly, displacement will be the shortest distance between 2 points. So here we go. If we solve it, like you will show as the circumference of a circle, circumference of a circle is equal to 2 pi r. R is the radius given here. But if it is covering the distance covered during half revolution, will be 2 pi r by 2, that is pi into r. So this is the distance calculated. Now if the question, now the next point we have to solve is the displacement. This was the distance. Now displacement will be, see, this is the circle. If the point begins, if the person starts walking along this path and reaches here. So where he is covering? He is covering the diameter, isn't it? So displacement will be nothing but twice the radius, that is the diameter is covering. And half of this whole circumference is nothing but this pi r. Is it clear? So the question number 3 is solved here. Now let's move on to the next question number 4. Now this question I had taken it from the NCERT book. It seemed to be a bit twisted, but it's not that difficult. Now let's solve this. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Now remember, read the question twice or thrice till you understand it better. Like a farmer moves along the boundary of a square field. Now when the boundary of a square field is given, the first thing it should come in mind that the perimeter of the square. Perimeter of the square is 4 into side. That means the farmer is moving 4 into 10, that is 40 meters, moving in how many seconds? 40 seconds. Now here it is asking us to find out the displacement. There is nothing to do with the distance, but we have to use this to calculate the displacement. How it has been done? Let's see. Let's move on to the screen again. I will be solving for you. Now let us recall what was there in the question. Side of the square field was given. Side of the square field was given as 10 meter. Then from the side we can calculate the perimeter. It will be 4 into 10, that is 40 meter. Now total time covered, it's already given total time that will cover. Total time covered is equal to 40 seconds, isn't it? It's given there. Now, to find the displacement, we are asked to find the displacement after a given time. Displacement after 2 minutes 20 seconds. Now, what is that? 2 minutes is 160 plus 20, that is, sorry, 2 minutes is 120 plus 20, that is 140 seconds. Now, we will have to use our junior class concept, that is unitary method. Like for 40 seconds, it took 40 seconds to cover 40 meter. In 1 second, one will cover 40 by 40. Now in 140 seconds, one can cover 40 by 40 into 140, that is 140 meter. Clear? Now this from 140 meter, we will use to calculate the number of rounds it has, the farmer can make. So the number of rounds made by the farmer is 140 divided by 40, because for one single, this total distance is, single perimeter is 40. 140 divided by 40 is 3.5 rounds one will make. So in total 3 rounds, there won't be any displacement. Only in the 0.5 round, means half of the rounds, 3.5 rounds. This is nothing but 3.5 round. That means for 3 total rounds, there will be no displacement. Only for this half round, there will be displacement. So, like in this case, This is the square field. So 3 times the person is moving along ABCD. 3 times he has moved. But for half of the term, 3.5, half means 1 here and here it stopped. That means we have to calculate the same distance between these 2 points. So let's calculate the displacement for this half round. So displacement will be square root of the 2 sides, square of 2 sides, that is square root of 100 plus 100, that is square root of 200, that is 10 root 2. 10 root 2 is nothing but 10 into 1.414, that is root 2 value, 1.414 into 10, it will give us 14.14 meter. So this becomes our answer. So I hope this understanding is clear here. You are able to follow what I have done. Okay. Now let's proceed to the next slide. Now next slide we have work to do. So don't get scared, just one question for you. You have to answer this. Write your answer in the comment section. Even write to me how it was learning. And if you have any suggestions, you feel free. You are open to write, give your feedback so that I can be more better next time. Now this is the homework. It says that Peter walks 2 kilometers due west, 1 kilometer due south, 1 kilometer due east. Then what will be his resultant displacement? This sort of sum we have already discussed in previous slides. Follow the video well and start answering. I will be waiting for your answer. Now let's reprise what we have done so far. We studied or learned here about the distance. It's nothing but the total length of the part that body covers. The shortest distance traveled by the body in a particular direction is displacement. Then we learned that distance has only magnitude, whereas displacement has magnitude as well as direction. So it's called as vector, distance is called as scalar. Displacement can be 0, whereas distance can never be 0. Distance can never be negative either, whereas displacement can be positive or negative. So this is the end of the lesson. Now, as always said, please feel free to connect. Till then, keep learning. Thank you.